Awesome. All right, for those people that came into the room, let me introduce myself again. I'm the Vice President and GM of Inspur Systems, Cloud Data Center Division here in the US. And today's topic, we are going to talk about convergence in open hardware platforms. So let's take a look at an overview of what's happening today in the open hardware community. So you're all here for OCP. So OCP started back in 2011 by Facebook. And the board members in OCP include Facebook, Microsoft, Intel, Rackspace, and Goldman Sachs. So we all know the OCP board members have been using OCP heavily and adopting OCP. But outside of the OCP membership, the adoption has been challenging. Until recently, the last 2 years, adoption has gone up a lot. So in 2017, finally, non-board member revenue for OCP equipment actually surpassed $1.2 billion. So it has been a great accomplishment on the OCP Foundation for doing this and attracting more and more valuable members into the community to together create platforms and modular building blocks that would actually sprinkle across all the different hardware platforms today. So Inspur is part of those members that are actively pursuing and implementing technology that would contribute to the OCP community, and we became solution provider and platinum member in 2016. And OCP has done a great job also in attracting other open hardware projects into the community. So a good example of that is Project Olympus, started by Microsoft in 2016. And then in 2017, Microsoft, 1 year later, decided to contribute Project Olympus into OCP community and contribute the design into the OCP community. And Inspur is also working with Microsoft to develop the 4-socket server for Project Olympus for their AI workloads. And then in 2016, Microsoft acquired LinkedIn. And in 2017, LinkedIn came up with Open19, another open platform. And currently, Inspur is the lead vendor for Open19. And Open19 is contributing their designs. They announced in this morning's keynote that they're contributing the Open19 into OCP as well. So then there's ODCC. ODCC is the Project Scorpio. It's an implementation that was started by Alibaba, Baidu, and Tencent in China. And currently, Inspur is the largest provider of ODCC rack scale platforms in the world today, capturing over 60% of the market share for ODCC. And then there's the Intel RSD, Intel rack scale design. So Intel started the RSA back in 2014, rack scale architecture. And then in 2016, they renamed it into RSD, trying to put more ammunition behind promoting the RSD design, which is a composable infrastructure. Most of the composable infrastructure designs out there currently are Ethernet-based, and Inspur is now working with another startup company called Liquid to introduce a PCIe fabric for composable infrastructure, which is making it possible for you to very quickly and dynamically compose bare metal hardware in seconds. So if you want to take a look at how that can be done, you can go to the Inspur booth. We have a live demo there. And then we also have a session on composable infrastructure together with Intel and Liquid in our booth later this afternoon. And while all this is happening, Inspur also got into a joint venture together with IBM to introduce the OpenPower platforms for AI solutions and develop products suited for AI workloads. Because the Power 9 processor has the NVLink built into the core. So if you use Power 9 server architecture, the bottleneck between CPU and GPU communication can be much reduced. So with all these going on, Inspur is the only server vendor today that leverages all of the modular building blocks that we came up with for our customers in all the different platforms, and we support all the open hardware platforms today. Okay, so let's take a look at the rack scale product lines that Inspur is trying to contribute to the OCP community that we have become such an active member and participant in. So currently the general purpose compute node, it's already contributed and got OCP accepted. And we're in the process of contributing another 3 compute nodes into OCP community. And we are contributing a storage JBOD into OCP accepted as well. That's in process. And then another 2 AI-based, AI-optimized solutions, JBOD, into the community as well. And all of these contributions are happening right now, and we hope to get the OCP accepted status for all of these nodes in Q2. And then one of them, again, it's in production for the compute node. So let's look at the systems that we contribute or plan to contribute into OCP in detail. So the first one I want to mention is the 1OU 3 compute nodes that we are using a motherboard that's already OCP accepted called the San Jose motherboard. The uniqueness about this compute node is it actually is a 1OU with 3 nodes across. So if you know a little bit about the Facebook implementation, the Tioga Pass motherboard, the Facebook implementation has 12 DIMMs on the top and 12 DIMMs on the bottom. So because of the way that it's designed, the motherboard cannot fit into a 1OU space. So Inspur decided we are going to do a slightly different modification to the Tioga Pass implementation. Instead of having 12 DIMMs on the top and 12 DIMM slots on the bottom, we just have 16 DIMMs on the top. So that would allow us to install the motherboard into a 1OU chassis and give you double the density in the same rack space. So this is very optimized for HPC applications. And then we have the 2OU 3 node across, same implementation as the Facebook, where you can have 2 OUs across, and then we introduce multiple platforms for the 2OU form factor. So you can have a general purpose node that we have already contributed into OCP, or you can have a balanced node, or you can have a high I/O configuration where you can have 4 NVMe disks along with 3 half-height, half-length PCIe add-on cards. Then we have this high-density storage JBOD that we are contributing. It's in a tray form factor, so there's 2 trays in 2OU, and each tray has 17 hot swap 3.5-inch drives. So 17 on top, 17 on the bottom, then you get 34 3.5-inch drives in 2OU form factor, which is very, very high density and very good for multiple, you can cascade multiple JBODs and then get a very good cold storage solution, or you can have a warm storage or a hot storage solution. And you can pair this very nicely with the 1OU compute nodes that I introduced earlier. And then, of course, the Project Olympus, started by Microsoft, introduced by Microsoft in 2016 and contributed to the community 1 year later in 2017. So Microsoft has been doing a lot of benchmarking with 2 socket servers versus 4 socket servers to see what the workload looks like for their AI applications and workloads. And they find with a lot of benchmarks that the performance improvement of using a 4-socket as a head node versus as using a 2-socket, the performance improvement can be up to 42%. And this is a very good achievement, and Inspur has been working very closely with Microsoft for this 4-socket Project Olympus implementation. Then again, if you had attended yesterday's keynote, Jason Waxman from Intel introduced the Inspur NF8260M5, the 4-socket standard 19-inch rack mount form factor server, which is similar to the Project Olympus node that you saw before. So with this node, what we're doing is we are doing a joint go-to-market with Intel to launch their Cascade Lake Intel Xeon Scalable processor family. And this is a very powerful server with support for Apache paths. So you can actually have 24 obtain persistent memory, which is Apache paths, paired together with 24 regular DRAM DIMMs for a very powerful 15 terabyte memory server. And you can also use the VNNI features built into the Cascade Lake for a lot of the inference workloads. And this is the first 19-inch rack mount form factor that is 4-socket that is being contributed into the OCP community today. And that is a great achievement, I believe, for Inspur and for the OCP community. And so this is going through the OCP accepted process right now, and we are hoping that by April, we'll be able to get the OCP accepted design approved. And then all the other community members can use this as a reference design to innovate more 4-socket server solutions for everyone to use. And then this is an AI JBOD that we have been shipping and using for many of our customers for the past 6 years already. We actually innovated this platform together with Baidu for their autonomous driving vehicle project, and we've been shipping hundreds of thousands of this JBOD node into the marketplace. And what we did is it was actually in the ODCC form factor, very similar to OCP. And then what we did is we converted the ODCC form factor into the OCP form factor. It's a very easy conversion for us because we just have to change and move the connector in the back for the bus bar to the middle from the side. So it would be an OCP form factor. And with a 16 GPU, this box can do not just GPU, you can also do FPGA with the box. So it's 16 PCIe slots. So if you want to do a training workload, you put in 16 PCIe GPU cards. Or if customers want to do an inference workload, they can just put in FPGA cards in there, 16 of them. It works just as well. And this has been very, very popular for a lot of the hyperscale customers that we have been deploying with. And we want to use that modular building block and introduce it to everyone else, including the tier 2 and tier 3 CSPs that we have been working with. And they can leverage the volume and the scale production that we have on this product to come up with great solutions for deep learning, machine learning. And then this is new. Again, we are in the process of contributing this. Instead of the PCIe form factor, we have the SXM2, which is using the NVIDIA NVLink in this new 30U 8 GPU SXM2 solution as a JBOD, another powerful alternative for training workloads. And then the highlight of what we are trying to introduce at the OCP Summit this year is the 6OU 16 GPU product that we built with the NV switch by NVIDIA. We can't contribute this design because NVIDIA will not allow us to contribute NV switch, and we have no access to the NV switch IP. However, this is available in a OCP form factor, so you're more than welcome to talk to Inspur. And if you have huge training workloads and you want to put together a mini supercomputer, talk to Inspur, and then we can provide you with the 6OU 16 GPU NV switch, the most powerful and highest density GPU JBOD today available in the market. And it's using SXM3, 16 of them in one 6OU box. Very high density, very powerful. So I want to conclude this talk with a little bit about Inspur's JDM capability. So we have been innovating a lot of technology building blocks that we can use across multiple platforms for OCP, ODCC, Project Olympus, Open19, which I show everything in the previous slides. And we want to be able to use these JDM product modules and provide it to everyone, including all the tier 2 and tier 3 data center operators, to make their life easier, to reduce costs, to make their data centers more efficient. This is the goal for Inspur, is to be able to make OCP and open hardware platforms to be readily available, easy to implement for the entire community of small, large, and hyperscale. So our, I don't want to do too much marketing talk here, but Inspur has been very active in the OCP community. And in addition to all the hardware modules that you saw earlier, we are also contributing the OpenBMC, which the keynote mentioned yesterday. Inspur is the first server manufacturer that's willing to open up our IP and provide OpenBMC rack management controller technology with OpenBMC and Redfish. So all the smaller operators, like tier 2 and tier 3 customers, can benefit from all the technology that we have innovated for the hyperscale. So now you can have full access to the full stack of management suite from Inspur using the OpenBMC technology. And you don't have to pay a premium. You don't have to pay additional to access a very rich management suite. And we also working with OCP community very closely to design the OAM, which was introduced yesterday as well, which is the OCP accelerator module that is optimized for AI workloads. So a lot of very interesting and exciting things happening, and we want everyone to benefit from all of this technology innovation that Inspur is doing today and going into the future. So thank you very much. Here is some additional information and URL links. So we will be posting this presentation on the YouTube. And then you can feel free to check out all of the information that's available for the foundation and all the new innovation that we are contributing and the specs that you can download. Thank you very much.